Good day, doctor. My name is Julie Walilin with the matrix number KH20033. Today, I will present the introduction part for the project 1, which is combination of the series and parallel circuit by using the Ohm's law and simulator. First of all, the Ohm's law states that the current through a conductor between the 2 points is directly proportional to the voltage across the 2 points. Thus, the Ohm's law is familiar with the 3 possible forms, which is V equal to IR, I equal to VR, and R equal to VI, where the V represents the voltage, I represent the current, and R represent the resistor. However, there is the difference between the series circuit and the parallel circuit. As you can see in the diagram, there is the different arrangement between the series circuit and the parallel circuit. For the series circuits, the components they are connected end to end, so there is only one path for the current flow. However, for the parallel circuits, the components they are connected side by side, so there is the multiple path for the current flow. For the series circuit, the current is the same in all parts of direct current circuit when the resistor and the lobes are connected in series with the voltage sources. However, the currents in the parallel circuit is not the same in all parts when the resistors are connected in parallel with the voltage sources, and the total current is the sum of the currents in each branch of the parallel circuit. Next, the drop of the voltage across each resistor in the series circuit is depend on the resistance of each resistor, where the drop of the voltage across each resistor in the parallel circuit are the same. The total resistance in the series circuit is the sum of the all circuit resistance. When the resistor value in the series circuit increases, then the total resistance in the series circuit also increases. However, the total resistance in the parallel circuit is the reciprocal of the equivalent resistance equal to the sum of the reciprocal of each branch resistance. When one resistor value in the parallel circuit is increases, the total resistance in the parallel circuit will decreases. However, there is the advantages and disadvantages for the series circuit and the parallel circuit. The advantages for the series circuit are: the series circuit can add the additional power devices, usually use the batteries, and the current flow in the series circuit will stop when a component breaks. The series circuit also can act as a current regulator, and the cost to build a series circuit is less compared to the parallel circuit. However, the advantages of the parallel circuit are: it is an independent component. When one component fails, then the others won't be affected. The parallel circuit also can ensure that all components in the circuit have the same voltage as the sources. And the parallel circuit also allows for the additional components in the circuit without changing the voltage. And the design of the parallel circuits are simple, safe, and reliable. The disadvantages for the series circuits are: if the single bar in the series circuit is blown, then the no currents will be flowed in the circuit. And if more bars are connected in the series circuits, then the light will get dimmer. The disadvantages for the parallel circuit are: the large currents are required, and we cannot increase the voltage in the parallel circuit, since the resistance will decrease in the parallel circuits. Next, power is the combination of the voltage and currents in a circuit. In a circuit, The electrical power is the rate at which energy is absorbed or produced within a circuit. The source of the energy, such as the voltage, will produce or deliver the power while the connector load absorbs. Then the power can be calculated by using the formula P equal to W over T, P equal to IB, or P equal to IR squared, where the W represents the watt, T represents the time, I represents the current, V represents the voltage, and R represents the resistance. That's all from me. Thank you.
Hi, I am Muhammad Safri. ID number is KH20030, and I will be explaining about the circuit drawing in this project. So first of all, a little bit something about before we go into the circuit drawing that I mentioned earlier. First, battery is a source of energy or voltage in the circuit that used to get the current going. Next, we got a resistor. Resistor that is used in the circuit is to oppose the flow of the current through it, and the strength of a position is called as its resistance. Next, we go to the type of the circuits. We got series circuit and parallel circuit. The current in series circuit flows only one path, as well as all parts in the circuit are connected to each other. Meanwhile, for parallel circuit, there are more than one path, so the current can flow on the different path from the positive end to the negative end. So each of these circuit has their own advantages as well as disadvantages. To list some of them. For series circuit, it is easy to design and build them, but if one component or bulb is broken, the entire circuit will not function properly. Furthermore, as the energy from the battery is shared by all devices in the circuit, so the further a device or component or bulb, the less efficient it will be. For example, the bulb will be dimmer than the first bulb. On the other hand, for parallel circuit, even though it is hard to design and build one, the circuit will work just fine if it got one or more component in the circuit is broken, because the current can avoid the broken component and flow in the different path, as I said earlier. On top of that, all components will be efficient, or in other words, all bulbs will shine equally bright. But on the other side, the battery will run out quicker than the battery in the series circuit. Alright, moving on to the circuit drawing in this project. The circuit that I've drawn for this project is quite simple, so the explanation will be short. First of all, the circuit will look like this. We can also have a battery with 10 volt and 5 different resistors with their own specific resistance. So first of all, resistor number 1 or R1 with 3.6 ohm, resistor number 2 or R2 with 4.7 ohm, resistor number 3 with or R3 with 4 ohm, resistor number 4 we call it R4 with 2.5 ohm, and last but not least, resistor number 5 we call it R5 with 1.3 ohm. So the R2 will be parallel to the R3, while the R4 will be parallel to R5, and combining that, R2 and 3 with R4 and 5 is series to the resistor number 1. And that is all for the circuit drawing. Thank you.
My name is Radhashini and I'm perempuan Sugumaran with the matrix number KH20026. So I would like to explain about calculation of power of the circuit. So as we see here, the one on the left side is our circuit. which consists of 5 resistors: resistor 1, resistor 2, resistor 3, resistor 4 and resistor 5. As we can see here, resistor 4 and resistors 5 are in parallel, same as resistor 2 and resistor 3 are in parallel. So in order to make it into a simplified form of circuit, in order to find our total current and voltage at each resistors, we are combining R4 and R5, R2 and R3 into one resistor. So as we can see here, it becomes a series circuit as we simplify the circuit. So in order to obtain the value of R4, 5, R2, 3, we use the formula for parallel circuit where resistance 1 over R total is equals to 1 over R1 plus 1 over R2. In this case, for 1 over R23 is equals to 1 over R2 plus 1 over R3, which sums up the value of R23 into 2.161 ohms. We use the same method to obtain the resistance value at R45, where 1 over R45 is equals to 1 over R4 plus 1 over R5, where R45 is equals to 0.855 ohms. So as we see here, we see it's a series circuit after combining R4 and R5 and R2 and R3. So as it is a series circuit, your R total for the whole circuit will be equals to R45 plus R23 plus R1, which is equals to 6.616 ohm. So that is the total resistance in the whole circuit. So according to Ohm's law, using the formula of V equals to IR, we can find the total current flow in the whole circuit. So V, which is equals to 10, is equals to IT times with 6.6162, where our total current will be equals to 1.511 ampere. So as we have already obtained the total current, now we can find the value of voltage at each resistors V45 and V23 by using the same formula V equals to IR. So we use as V45 is equals to IT times with R45, 1.511 times with 0.855, we get the value of 1.293 volt. So we know for in parallel circuit, total voltage is same as in each resistor. Thus V45 is equals to V4 plus V5. So we obtain the voltage of V4 as 1.293. With this value, we can find the current flow at resistor 4 as by using the same formula V equals to IR by Ohm's law. So your I4 will be equals to 0.517 ampere. We use the same method to find V5, which is parallel with V4. We get I5 as 0.994 ampere. So as we have already obtained the current value on resistor 4 and resistor 5, we use the same method for the combination of resistor 2, 3. So we're going to find the voltage at resistor 2, 3, where 1.511 times the 2.161, we get the value of 3.266 volt, which is the voltage of the combination of resistor 2 and resistor 3. As for parallel, V23 is equals to V2, which is also equals to V3. We get the value by using the value of V23 for V2. We get it as 3.266, which is equals to I2 times with 4.7. So in order to find the current value at resistor 2, we get the value of 0.695 ampere. So we use the same method to find the current value at resistor 3 as 0.817 ampere. So in order to find the power of the whole circuit, we have to use the formula of power, which is equals to voltage times the current. P is equals to IV. As we see here, for the whole circuit, PT is equals to IT times VT, which is equals to our total current is 1.511 ampere times 10, which is equals to 15.11 watt. So in order to obtain each and every value of power at resistor 1, 2, 3, 4, 5, we are going to use the same method or same formula of P is equals to IV. So as we see here, P1 is equals to I1 times V1, 1.511 times 3.6, which is equals to 5.441 watts. At resistor 2, using the same formula 0.695 times with 3.266. So the power at resistor 2 is 2.27 watts. At resistor 3, using the same formula again, 0.817 times with 3.266. So the power at resistor 3 is 2.667 watts. At resistor 4, P4 equals to I4 times V4, 0.517 times 1.293. So the power at resistor 4 is 0.668 watt. At resistor 5, P5 is equals to I5 times V5, 0.9943 times with 1.293. We get the power at resistor 5 as 1.285 watt. So that is how we calculate the power for the whole circuit.
Assalamualaikum warahmatullahi wabarakatuh, and good morning. My name is Muhammad Nabi Farhan bin Zulkifli and my ID is KH20024. Today I want to present to you our group project simulation and simulation result. For this project, our group choose to use the FAST software. We choose this software because it is free and we can get it anywhere online. Furthermore, the command system in the software is easy to manage and very user friendly. It also shows us the result very clearly, and we also easy to extract the result to put in our project report. Okay, the main purpose of the circuit simulation is to show us the flow of the current and the flow of the power in each resistor in this result. As we can see from the diagram below, our group choose to have 5 different resistors with a different value, which is 3.6 ohm, 2.5 ohm, 1.3 ohm, 4.0 ohm, and 4 ohm, and one voltage source, which is 10 volts in our circuit. This figure also shows us that the green line, this green line, stands for the flow of the current from the positive terminal, and the negative line, this negative line, stands for the exit of the current to the negative terminal. This negative terminal. Okay, and for the simulation result, we can get the power for each of the resistor. As we know, each resistor that we use in our circuit have a different value, and because of the difference in the value, we get all of the power for each resistor is also different. For example, the power for the resistor with 3.6 ohm value, we get the power is 2.056 watt, and for the 1.3 ohm, we get the 321 and 352 milliwatt. This shows us the difference in the value of the resistor came out of the power of the resistor is also will become different. That's all for me for today. Thank you.
Okay, hi. Have a good day to all of you. My name is BINTI. My ID number is KH20031. Okay, for my part, I will present the comparison table of calculated and simulated result. Okay, so this one is table 1. This is show the manual calculated value. So how we got this manual calculated value is by using the Ohm's law. When we calculate the current, voltage and power for all the resistor, which is R1, R2, R3, R4 and also R5. Okay, so the next table is the table which show the value of simulated result. Okay, so from this table, we are using a simulator. So from that we got a different value for all a different value for current, voltage and power for all the different resistor. Okay, so for the table 3, which is show the difference between calculate value using Ohm's law and simulated result. Okay, in my previous slide, I will show the table 1 and also table 2. So when we got the value of simulated result, we minus with the value of calculated by manually. So from that we got some difference value for all the resistance. Okay, for the next part, I will present the conclusion from the conclusion which we got from this circuit project. Okay, in this project we got more knowledge, we got more ideas how to calculate the value of voltage, current, power, and we also verify the result by doing this project. Okay, we also know more about how resistor works. Okay, what we got from this project, we can calculate the value by manually and also by using a simulator. So from that we got the value for power at R1, R2, R3, R4 and also R5. Okay, so from our result we got a small difference value between the simulated result with the compared with the manually calculated value. So from that, this is to show to do development of a mathematical model for the object leading to system of equations. Okay, from our project circuits, we know the benefits by using a simulator in electrical circuit. Okay, so there are 3 benefits, which is for the first benefit, is a simulator is to test a circuit before it is built to make sure it will function properly and efficiently. And for the second, the simulator can be used to stimulate circuit before building an electronic device. Okay, so for the third benefit of simulator is there is cutting costs on expensive materials and replacing the components with their performing alternatives. Okay, furthermore, we also learn how the uses of Ohm's law to calculate the electric potential in a circuit. Okay, we know the formula of Ohm's law which are using in electrical circuit. V equal to I times with R. Okay, so from that we also got the value of power, and the Ohm's law is very extensive in electronics formulas and calculation in combination series and parallel circuit from this project. Okay, so what we got from this project, which the objective from this project is accepted, which is the combination of series and parallel circuit analysis using Ohm's law and simulator accepted in our circuit project. Okay, that's all from our group presentation. Okay, thank you.